Today, for my video lesson, I will be talking about S&P waves, also known as primary and secondary waves. This is also how we feel earthquakes and the waves that come from them. How are S&P waves formed? They are formed by the releasing of stored energy on a fault line during an earthquake. This occurs by the rocks building up so much elastic potential energy, and then at one point, releasing it because they cannot store anymore, and that is where the waves come from. The definitions of P and S waves. P waves are primary waves. They are the fastest seismic waves, and they reach recording stations first. Recording stations are also places all around the world that record when they feel earthquakes and are in communication with all the other stations to figure out where earthquakes come from, which I will be getting into later. P waves are also longitudinal waves, which, as you can remember from the slinky, is when you push the slinky out and pull it back in towards you. This means that they do not really need strong bonds between them to move between any materials. Secondary waves are slower seismic waves, and they reach recording stations second, because they travel much slower to get there after P waves. They are transverse waves, which means that they move either up and down or side to side. This means that they need much stronger bonds to move between materials. So the movement through Earth. P waves move through solids, liquids, and gases. This is because they are a push-pull material, which means they can push and pull, and they do not really need strong bonds for that to occur. This means that they can pass through the whole Earth, including the crust, the mantle, the inner, and the outer core. For instance, this is the example of us lining up together with all our arms linked and Dr. Dave pushing the first person to the side. As you can tell, we all moved very fast, and we all moved, even when we were in liquid form, which means we were unlinked. For S waves, they can only move through solids. This becomes they need strong molecular bonds to move through, which only solids have. This means that they cannot pass through the inner and outer core, so they stop when they get there. They create a shadow zone, which means that, as you can see, it will not go through this inner circle, so it will only go out in all directions, which means this whole part of the Earth will not get the S waves. They will only receive P waves. Our example of this is when we were chained up, and half of us were linked up, half of us were not, and Dr. Dave pushed us forward. The people that were linked, who were solids, you traveled a bit slower than a P wave, but you still moved together. However, once you got to the unlinked station, you stopped moving, and there was no push or pull happening. Finding the epicenter, or where the earthquake happened. Seismologists calculate where the earthquake's epicenter is by seeing the differences in time that it takes for an S and P wave to arrive at different stations. So, looking at this picture right here, you can see for this second one, it's the Socorro in Mexico, that from the P wave to when the S wave arrived there, it was 3 minutes, which means it was 1,800 kilometers that it was between the two of them. So, you take this for at least 3 stations, and you figure out, so it means you take this number right here that you get, and you kind of make a bubble from that station, 1,800 kilometers out, make a little bubble around it, and that is where the earthquake could have happened on this line. You do that for multiple places, and then you see where they're overlapping, which, for instance, is that little red star right there, and that is where the earthquake occurred. Damages from waves. P waves cause much less destruction, as they are not as strong, and they only move horizontally, which means they only shake. This gives the chance for cities, especially that are ones further from the epicenter of the earthquake, to warn the city that there's a bigger earthquake coming. S waves are very destructive, as they have a much larger amplitude and move both vertically and horizontally, which means they shake everything a lot more than the P waves do. Thank you.